Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to my channel and also kindly request our members to subscribe, engage us in the comment section and also ring that notification bell to be getting updates in our various uploads in mathematics and sciences. I'd also like to request our members to be checking our description boxes. I'm going to put a link of other videos in terms of our playlists, which are going to be complementing on various discussions that we do in different topics. Now, in our discussion today, I'm going to look at the concept of electromotive force. And this is going to be building up on the previous discussion we have had on the concept of electric field and, of course, other aspects of charges and the potential difference. Now, in this specific case, I've talked about the concept of electromotive force. But later on, we're going to see that basically the concept of force in this particular case is not going to be an elaborate aspect of the various aspects of a force which we have discussed in some of our videos. And of course, I'm going to explain that one in perhaps a summary form as we go by. So in this particular case, I've divided this specific section into an illustration of four particular figures. These are going to give us a summary of what basically the concept of electromotive force entail. Now, we have discussed in some of our videos the various aspects of a circuit, and we said that this basically is going to consist of various components which are going to play a vital role in order to assist us achieve a particular function. Now, in a sense, the first case which I've given in terms of an illustration consists of a circuit, and this is going to be assisting us explain how internal resistance of a cell can be measured. But of course, we're going to use this simple circuit in trying to explain this specific aspect of electromotive force. Now, they explained from our last discussion that basically we're going to be having the arrow indicating the flow of current in this specific circuit from the positive terminal of this specific source. And we're going to refer to this one as particularly a source of electromotive force, which is of course our topic of our discussion for today. Now, in this specific aspect, and therefore we're going to see that a circuit component which consists, or a circuit which consists of a components which have got a source of electromotive force, or the source which is going to be a potential difference as that I've indicated, is going to be allowing the flow of current so long as this specific circuit is complete. Now, in this particular case, we are going to see that the flow of current basically is the motion of charges in this particular circuit. But for us to ensure that the charges are going to move in this specific circuit, we're going to require a device that can pump it. So we're going to assume that this specific flow of current is basically like a fluid which is confined within a specific cycle. And therefore, we are going to require a pump in order to ensure that there is a continuous flow within that specific loop of the liquid. Now, in this particular case, then therefore, we can take that specific analogy to imply this specific kind of a circuit. And therefore, we are going to see that in this particular case, we're going also to have this specific section for this symbol. And this is going to imply the electromotive force. Now, the potential difference between the terminals of this specific electromotive force, of course, is going to be having, or is going to be having an flow of current to the external circuit, unless these specific terminals have been joined using these various other aspects. Now, we're going to look at some of the characteristics of this specific aspect which we have mentioned. And therefore, in this particular case, we are going to, this particular circuit is going to require a device, as I've said, to pump these specific charges within this specific loop which I've mentioned that constitute a circuit. Now, therefore, we are going to look at what basically this aspect of electromotive force is, now that we have identified what we refer to as the source of course, electromotive force. Now, electromotive force basically is going to be what we refer to as a source of electrical potential energy. That is defined as the amount of electrical energy per coulomb of a positive charge as it's going to, or as the charge passes through the source, from a low potential to, or from a low potential to a high potential. Now, in this specific case, I'm going to match this specific aspect of illustrative figure 1 to, or figure A to figure D. And this is going to assist me. Now, in this particular case, I've given what we refer to as a section of a conductor. And this particular conductor is going to consist of a cross-sectional area. So basically this is a D. It's going to consist of a cross-sectional area which I've given in terms of A. And therefore in this specific section, this particular conductor is going to be of length L given as such. And of course this particular cross-section for identified as A is got opposite cross-sectional area at this specific point along this particular end of a length of L. Therefore, we are going to have this specific section consisting of a high potential in terms of the difference between the potential at this specific point 1 and this one. This is going to be higher and this is going to be a low of potential. And therefore, the current is going to flow from this specific section towards that one. Now, I've indicated this one using the, of course, a V here to avoid that contradiction. So the difference between, now suppose I was to use this specific initials for VA as the potential at that specific point, and then there is VB as the potential at this specific point. Now the difference between VA and VB is going to give us delta V, which is the potential between VA and VB, and that is going to give us what we refer to as a potential difference. Now in this particular case, then therefore the flow of charge is going to be realized due to, of course, from this higher potential to the low potential, as I've said, and that is going to constitute the potential difference which I've given in terms of that delta V. So any motion of charges from one region to another is going to define what we refer to as current, and therefore in this specific case we are going to realize this specific aspect of current due to the flow of charges. And in this case we can give current in terms of this specific notation, which basically is going to be I given as such. Now this can be defined as a ratio as I've said, which is basically going to be given as a dq over dt. So this is going to be the flow of charges with respect to time given as this is specific, of course, equation. Therefore, we can have this one given as the current is equivalent to dq with respect to time given as such. Now, in this case, this is one of the definitions that we're going to come across from this particular illustration, which I've given above. But we're going to see that there is a specific kind of rules which we are going to follow, which convectionally are going to assist us in trying to identify the direction of a flow of current. And this, of course, is going to be depending on the positive and negative charges of materials, which we are going to refer to as conductors. Now, in this particular case, I'm going to consider the illustration for B and C, and that is going to assist us identify which is the convectional way in which we can identify the flow of current. Now, from my illustration B, which I've given, now suppose perhaps if I may give a recap for this, we are going to have this specific conductor given as such. We have talked about the concept of electric field and of course what we refer to as electrons. So the force or the electron in this specific field is going to be experiencing what we refer to as a force. Now suppose we have this one as an electric field given as such. So the presence of electron in this specific field is going to experience what we refer to as a force. And in some of the previous discussion, we have basically given this force as of course the product of charge and the electric field given as such. Now in this case, we are going to see that for this electron which has got a negative charge, it's going to experience a force on it due to the presence of this specific field, and this is going to be in the direction opposite to the direction of this particular field. Now in this case, I've just given this arrow to indicate the vector field, but this field is going to be given in this specific direction, and therefore we're going to expect the electron to be moving in a particular direction, but basically which is going to be opposite this specific direction which we can give in terms of that particular illustration. Now therefore that's going to give us a clue on one of the ways in which we can identify the flow of charges given the direction of the electric field. But for this case, we're going to consider the general case for B and C, which is going to consist of a positive and negative charges. Now, as we have been saying, of course, one of the ways in which we can identify the flow of current is a flow of charge. And in this case, this can be either a negative or a positive charges as we have given them above. Now, if we consider these specific charges to be, of course, positive charges, then we're going to see that convectional current is going to be treated as a flow of these particular positive charges. And of course, we're going to disregard whether they are either positive, negative, or both. So in this case, if we are going to indicate the flow of current for this specific illustration for P, we're going to indicate that the flow of currents is going to be convectionally flowing towards this flow of positive charge, and that's going to be the direction of that particular current. But if you consider the second one, and this is a case, for instance, if I can give this one specifically for metals, metals consist of electrons which are going to be, of course, moving towards a specific direction during the flow of current. And therefore, we're going to expect that basically this motion of charges is going to be indicating the direction of a flow of charges. But basically, we're going to see that in our illustrations, we're going to consider that the moving charges are electrons, but the current still is going to point in the direction of positive charges. And this is going to be a conventional way in which we are going to indicate the flow of charges in our specific illustrations. Now, of course, that is going to assist us in trying to indicate various ways in which we can represent the flow of charges and these other concepts. And I assume that these particular illustrations which I've given for this specific case is going to assist us in trying to identify an aspect of electromotive force in terms of direction and other aspects of current and then fields which I've given. Now, in my next illustration, of course, I'm going to use this specific diagram exclusively, and that is going to assist us understand various aspects of the concept of electromotive force and the relationship between various aspects which I have described in this particular case, especially on current, the field, and of course, the motion of charges, which I've given in an elaborate way in this particular discussion. So kindly check our description boxes for various links of other videos, and also check a link which I'm going to put for this next video, which is going to assist us, of course, in finding a way of quantifying this electromotive force. So that is it for now, guys. Bye, God bless you. Catch us in our next video.